We're looking at Pythagoras theorem and its role in problem solving. Let's have a look at this diagram. We've got a photo of two skyscrapers, two tall buildings here, and we've got Batman, who's up there. You can just barely see him. There he is, little red dot. Batman wants to go from there down to the top of the other building on the edge. And Batman's going to do that by rigging up a tight cable with no slack in it. So you can see he's going to go down that cable. He's pretty good. He can make the cable, he can throw a line and it will land in exactly the right spot. And we know, Batman's a superhero, so he can do all these things. So how long does the cable need to be? We'll call the cable C. How long is C? Well, luckily we know how far apart these two skyscrapers are. This distance across here, which I'll put in different colour, straight across here, the distance that the buildings apart is known. It's 26 meters. The distance vertically is known as well. Vertically we know we have 91 meters. Those two lines create a right angle triangle. So we can start solving the problem. So we can predict, well, it's a right angle triangle, so we're going to use Pythagoras' theorem. We've got two known sides, so let's clarify what have been given. Two short sides. We also given a right angle triangle. What is it that we have to find? We have to find the hypotenuse. So we know what we need to do now. In the solve, we have to find the hypotenuse. So hypotenuse to be found. To solve it, we know we need to use Pythagoras' theorem. So let's go and solve it. C squared equals a squared plus b squared. Substitute the values in, 91 and 26. We add those together, we get 8957. To find C, the length of the cable, we have to take the square root of 8957. Using a calculator, that comes to about 94.64 meters rounded to two decimal places. So about 95 meters of cable. Reflect. Does the answer make sense? Does it seem reasonable? Yes, it does. One thing that's reasonable about the answer of 95 would make sense because it's bigger than 91, which is, you can see back in the diagram up here, 91 is one of the shorter sides, 95 too is bigger than 26, which is the other shorter side. It's a reasonable answer. And I guess one other thing you could think about, he might need a bit more than 95 meters because, if he's needing to tie it down or something else. So certainly 95 at least. So that's how much cable Batman needs. Let's look at a second example now. Okay, when we're problem solving, sometimes we get a worded question. So we have two skyscrapers, again, good. Two skyscrapers are located 35 meters apart. A cable of length 82.3 meters links the tops of the buildings. Now this is similar to the previous question. If the taller building is 280 meters tall, what is the height of the shorter building? That's what we've got to find. And we've got to round it to one decimal place. Well, if we can make a right angle triangle, so if we can find a right angle, that means we could probably use Pythagoras. So Pythagoras' theorem. Clarify, what have we been given? And another thing to clarify would be to draw a diagram. So let's draw the diagram first and then write down the information that we've been given. Started by drawing the edge of the taller building, it's 280, and along the ground, assuming it's flat ground, we've got 35 meters, and that's this horizontal line. Now I'm going to draw the shorter building. I don't know how tall it is, because that's what we've got to find, so I'm just going to draw another straight. I'm assuming it's a straight and vertical building, and it's 35 meters, so we might just stop there. We don't know how long it is. It's a guide. So these buildings go off, they've got a width, but that's not important. It's just these two lines, and because we need to find the height of the shorter building, we need to find, as I said, a right angle triangle. So we've got this cable length of 82.3, so let's put that in so we can see it. There's the cable. The cable links the tops of the buildings, so we're assuming that means from the edges. That's an assumption we make, otherwise you can't really do the question. And if we do this, we've got our right angle triangle, just like what we were trying to predict before. It's got 35 along here, and we've got 82.3 meters along there. That comes from the question. So we have the hypotenuse, which is 82.3 meters. We have one of the shorter sides, which I'm calling B, 35 meters, and we are trying to find the other short side, which I've called A. We can now go and solve using Pythagoras. We always write Pythagoras' theorem down as our first step. C squared equals A squared plus B squared. We substitute the values in, so we have 82.3 squared, we have A squared, we have 35 squared. Since this is a shorter side question, we know we're going to use subtraction, so we've got A squared plus 35 squared equals 82.3 squared. We want to get A squared by itself, so we need to subtract 35 squared from both sides. So A squared equals 5,548.29. Now we need to take the square root. We get 74.49 once we've taken the square root. Now what does this mean, this number 74.49? Let's go up. 74.49 is A. So that's 74.49, that distance A. Now let's reread the question. What is the height of the shorter building? The shorter building is the taller building minus, because the taller building goes right up to there, minus the bit that comes down from the top, which is 74.49. So it's 280 take 74.49. So doing that, you get 205.51 meters. Does the answer seem reasonable? Yes, it does. It's reasonable because, well, let's look at the final answer. 280 versus 205.51. They are kind of similar, but we see one building is clearly taller than the other, so that makes sense. Also, the 74.49 up here has to be less than 82.3 because 82.3 is the hypotenuse and 74.49 is the shorter side. Go tackle some problems now.